Today's session, we're going to talk about land breezes and sea breezes. Okay, so when you go to the beach, you first walk out there and you're in your bare feet. What always happens is you get your feet under that sand and the sand is crazy hot. So you run around like a scalded ape, your feet are burning, and there's only one place that you can go to get any kind of relief. And you see that water down there and you get your feet in the water. So my question is, why is it that when the sun is heating up both the sand and the water at the same rate, the same sun is heating them up, the water is cooler than the sand? And the answer is something called specific heat. Okay, so specific heat is the amount of energy that is needed to heat up a substance. So some things need more energy to heat them up, and they heat up faster, and that's the case here. Sand heats up faster, but it also cools down faster. Water heats up slower, and it cools down slower. And this is what basically is responsible for all the weather that we deal with. Okay, so when we go to the beach, we know that the sand is hotter. And so because the sand is hotter, the air above it becomes hotter. So the hot air above the beach, we know that hot air rises, right? We know that the water is cooler. When we go to the beach during the day, the water is cooler. So cold air sinks, right? When this air is coming down, we know that whenever we find air coming down, we get high pressure. And whenever air is rising down here, we have low pressure. And we also know that air moves from high to low. So during the day at the beach, we have this situation going on. We have high pressure moving towards low pressure. So if you go to the beach during the day, it's almost always windy with the big breeze coming off of the ocean. The breeze is coming from the sea. And for once, science made it easy. The breeze coming from the sea is known as a sea breeze. Okay, we're going to find the exact opposite to be true at the beach at night. So remember, we said that water heats up slower and cools slower. And the sand heats faster and cools faster. All right, so during the day, we might find that the water maybe at its hottest got to 70 degrees. And at its coldest, at night, maybe the water drops to 60 degrees. But during the day, the sand may get all the way up to, say, 95 degrees. And the land at night, if you ever walked in the sand at night, you know that it feels really cool on your feet. Let's say it gets down to, say, 50 degrees at night. So during the daytime, the sand is higher, which is why we have the sea breeze going on. But at nighttime, we can see that the water is going to be warmer than the land. So we're going to have the exact opposite. At nighttime, when the water is higher, water is hotter, we're going to get air rising over the water and falling over the colder sand. Again, we have high pressure down here. We have low pressure right here. Whenever air is coming down, it's high pressure. Whenever air is rising, it's low pressure. Complete this. Now this loop that we see here and here is what's known as a convection current. Okay? So anytime we have hot air rising and cold air falling, we know it as a convection current. Okay? At night, when the breeze is coming from the land, again, science made it easy for us for once, and we know that as a land breeze. Okay, so when you see a question about a land breeze or a sea breeze on a test, what I want you to do is just think about it. When you go there, where is it hot? During the day, you're going to find that it's hotter over the sand, and so it rises, because hot air always rises because it's less dense. Right, so think about, where is it hotter? During the day, it's hotter on the land. During at night, it's hotter on the water.